Lesson 4B, we're getting even more narrow. So last time, in the last lesson, we learned how to get all of the possible ones. So we're not trying a bunch of random numbers that couldn't even be factors, right? So we narrowed our possible zeros a little bit. We're going to narrow it a little bit further with, we can have zeros between this range and that range. So we may be able to throw some off the top and some off the bottom. Let's dive in and see what it is. Okay, so we're going to start with this formal definition, right? And we're going to put some meat on it with an example here in a minute. So if f is a polynomial function with a degree greater than or equal to 1, right? So it's at least a linear function. It's not a constant function. It has real coefficients. So this time with this one, with this, we get this, it just has to have real coefficients. So this upper and lower bound test works even if those coefficients aren't integer numbers like that last test, right? So this works for all of them. So it does work for integers, but it also works for rationals or irrationals or whatever, right? So it has to have a positive leading coefficient. So it doesn't work. That let's make sure we're kind of following along. It has so it only works for functions that look like either this or like this, not for functions that look like this. It doesn't work for this, and it doesn't work for ones that look like that. This test only works if it's got positive leading coefficients. So either this kind or this kind, not these kinds, right? Then again, just like the last test, we're going to divide by something like this with synthetic division. If C is negative or 0, right? Like this guy, then and every number in the last line of the division alternatively non-negative and non-positive. So why does it not say it alternates between positive, negative? Well, 0 would count in either one of these categories. So that's why, right? That's why it's written all in the negative instead of in the negation instead of in the just without the non on there. Then C is a lower bound. So what does that mean? Let's see what that means. So if we have a function, something kind of like, I'll take a little second longer to draw something that's a little bit more reasonable. Okay. A lower bound means that it is to the left of the lowest zeros. Like in this little example, this would be the lowest. This would be the lowest 0 right here, this guy here. And so anything that is to the left of that is a lower bound. Anything that is. If it's anything over here. So there is not a single lower bound. All that this lets do is say this is a lower bound. So we could go just a little bit over here and we would have a lower bound. Right? If C is greater than or equal to 0, so if it's positive, so if it's a positive number, so if it's over here, then and every number in the last line is non-negative, so it's positive or 0, then it's an upper bound. So it's something to the right of the biggest 0, right? So that's what lower bounds and upper bounds are. Let's put some meat on this with an example. Here we go. There's our example. So we want to determine an interval in which all real zeros of this function must lie. Explain your reasoning using upper-lower bound test. So let's do the synthetic division is what this is saying, right? Then we're going to find all the real zeros. So what we're going to start out with is I'm going to start out with something that y'all probably did in the last lesson on the homework is I'm going to go to the calculator and I'm going to kind of get a picture of what's going on. And I'm going to get what I think the lower bound is, and then I'm going to confirm it with the upper and lower bound test. Okay, so let's go to the graph. This guy right there. So here is the graph. Now I put it in there, like you probably would do in your calculator, and the window settings that I'm using are like this. Okay, I went on the X from -20 to +20. And from the Y, I went -100,000 to +100,000, right? You don't have to use these exact numbers to get a picture that's worth using. This is just what I did. And again, if you're doing this and you're kind of YOLOing on your own, just you're going to kind of play with the zoom or the window settings until you get something where you can kind of see something. And this is what it looks like, right? So the lowest 0 looks to be right here. And if I count 1, 2, 3, 4, 5, we count to negative 12. So anything to the left of that should be a lower bound. So if this is negative 12 or something near negative 12, then a lower bound could be 13. So, and then the smallest or the biggest bound looks to be if I kind of if I do a little bit of traceage, it looks to be maybe 1. So if I plug in something to the right of 1, or I could plug in 2, or I could plug in 1, or whatever else, all right, then I might get something. So I'm going to go ahead and plug in 2, which is actually different than the answer in the book, but it's more for sure it's 2. It just looking at this picture without going to look at the table, it's hard to tell where the 0 is in here, whether it's 1 or 2. So I may as well play it safe and go up to 2, right? So let's do that. So we're going to assume this interval, and we're going to confirm it. We're going to assume that the interval is between negative 13 and, what did we say, 2? Yeah, so somewhere between those two things. Now, it says and interval, so you could have different possibilities. As long as we're to the right of that last 0, then it technically works. As long as we're to the left of that lowest 0, then it technically works. I like to try to hit, within 1 or 2 of the zeros, of the nearest upper integer and the nearest lower integer, just because it's easier to kind of work with. So we're going to confirm this and see if it works. So let's test this negative 13. So negative 13, which is a bit of a painful thing, but that's fine. Negative 13, and we're going to plug in all the coefficients here. 6, 70, negative 21, 35, negative 12. We got some junk to multiply. We can do this. So bring down our 6. 6 times negative 13 is negative something. Negative 60 plus 18 is negative 78. I'm going to confirm all of these on the calculator just because I'm feeling like mistakes are liable to happen. So 6 times 13 is in fact 78. So negative 78. 70 plus negative 78 is negative 8. That's easy peasy. Negative 13 times negative 8 is positive something. Positive 80 plus 24. So 104 is what I'm thinking. So let's see. 13 times 8. 104. That looks great. So it's positive 104. Negative 21 plus 104 is positive, because this is bigger, positive 83. And then negative 13 times 83, we could do that in our head, but I'm not even going to worry about it. 13 times 83. Double check I put it in right. I did. Enter. So 1,079. 1,079. 35 plus 1,079 is 2,014 maybe. I'm just going to confirm. Again, I'm feeling that mistakes will happen if I'm not careful. 1,100. Yeah, see, I was about to make a mistake. Yeah, of course. 1,114. That's an easy mistake to make. I see that on people's homework problems all the time. So that times negative 13 times negative 13. Hello. 1, 3. Enter. Negative 14,482. Negative 14,482. And we don't actually care what this is. Now, something has happened here. I think I made a mistake. Give me half a second. I did make a mistake. I told you mistakes were, I was feeling it. This should have been negative, because negative times positive is negative, which means this number is wrong. Because I knew this didn't match what our picture was, and it doesn't match what I have over there. So, mistakes were made. So 1,007, is it 79? Yeah, 1,079 minus 35. Why did I subtract? Because the signs are different. We subtract, keep the sign of the bigger one. All right. So it's going to be negative 1,044. Negative 1,044. So try again. This times 13. Now it's going to be positive, whatever that is, because negative times a negative is a is a positive. So I'm going to plug in times 13. So I've said before, and I'll say again, that often it's a better idea to do the negatives with your brain and the just multiplication or division on the paper. That's often, not always, 13,572. 13572. So this plus negative 12 is 13,560. I don't really care what it is. All I care about is the fact that it's positive. But yeah, so does this work? So our lower bound test, this is exactly what has to happen. This bottom row, so it's negative if C is negative, so it is negative in this case. And we divide it, and this bottom row has to alternate, and it is a lower bound. So this does work. So we end up, since it's plus, minus, plus, minus, plus, so it's non-negative, non-positive, non-negative, non-positive, non-negative, right? Easy peasy. Let's check 2 and see if it works for the upper bound. All right, so the upper bound, we're going to test it with 2. So 6, 70, negative 21, 35, negative 12. Bring down the 6. 2 times 6 is 12. 70 plus 12 is 82. 82 times 2 is 164. 164 minus 21 is 143. That times 2 is 286, I think. That sounds right, but let's double check. I don't know why it keeps having delay every time I jump to the calculator. Don't know what's happening. Enter. 286. 6 plus 35. So far, it all is positive, which is what we want. 321 is what we said. 321. And then 2 times that, so times 2, 642, which would be 630. All of it's positive, which means this is, in fact, an upper bound. We already converted this as a lower bound, so this is a range. Now, if you tried 1, if you heard what I said and kind of hope for the best, 1 would also work, at least that's what it says over there. So there's our reasoning. There's the interval. Now we got to find all the real zeros. So P and Q and all of that nonsense like we did in the last video. Let me switch colors here. P in this case is, I'm going to do it plus or minus 12. And Q is plus or minus 6. So all the factors of 12 are 12 and 6 and 4, right? And 3 and 2 and, of course, 1, right? What about 6? 6 is going to be a lot of the same ones, which is going to be nice because we're going to have some duplicates. We'll make our list, so we're not going to have to list everything. Plus or minus 6, plus or minus 3, plus or minus 2, plus or minus 1, and that's it. So all the possible ones are these over these. So I'm going to do it in order like I like to do. So we'll start with this one, 1 over 1. So the possible ones are plus or minus 1, which both fit in this bound. So I'm going to list it, right? Both of those are in this range. Plus or minus 1 over 2, which also fits. Minus 1 over 2. Plus or minus 1 over 3, which also fits in this range. So it could be that plus or minus 1 over 6. You're like, it didn't reduce it at all. Well, it did. It took out some of the bigger ones, right? We can't have positive 12, positive any. There's a bunch of positives we can chuck out. It didn't chuck out very many of the negatives. In fact, it doesn't chuck out any of the negatives, but it chucks out some of the positives that we might have to try, right? Plus or minus. So now we'll go in the 2. So 2 over 2 is 1. We already listed that one, so I don't have to list that one again. 2 over 2 or no, what was that? Where I didn't do, I missed one. Oops. 2 over 1 is 2. I don't have that yet. So plus or minus 2. But plus or minus 2 over 2 is 1. I already have that. 2 over 3, I don't have 2/3. So I've got to do plus or minus 2/3. This problem doesn't say we have to list all of them. So I'm going to pause, time out, and I'm going to start testing some stuff that I have and see if we can narrow some stuff further before we list them all. It could be one of these, right? So we should try out some of what we have and see what's happening. And to make our life easier, I'm going to do like you probably would do, and I'm going to go over here. And I'm going to look at this. Be like, oh, remember we said negative 12 looks like it's a 0, so let's try negative 12, because that one doesn't get taken out by our range. So I'm going to try negative 12 and see if it works. So negative 12. Plug in our coefficients. 6, 70, negative 21, 35, and negative 12. So if we're real lucky, this will work. Draw our line, bring down our 6. 6 times negative 12 is negative 72. That's so far not bad, because 70 plus negative 72 is negative 2. Negative 2 times negative 12 is positive. Don't make the same mistake twice if we can help it. 24. Negative 21 plus 24. Okay, we're still looking pretty good. That's going to be positive 3, right? Negative 12 times positive 3 is negative. That's actually the mistake I made, isn't it? A version of that. Negative 36. 35 plus negative 36 is negative 1. Looking beautiful. Negative 12 times negative 1 is positive 12. We did it. We found a partial solution. So what we have at this point, I'm gonna do this in a light green. What we have so far is f of x equals x. Was it minus 12? Yeah, so x plus 12, right? It's going to be backwards. That x minus c, so x minus negative 12 is x plus 12. Flips the sign. And we go back into the factor. Times 6x cubed, right? It's one less than this one. This is, I think, this is the first example, at least in this little series, that's not just been a squared, but 6x cubed minus 2x squared plus 3x, and that's a 1, yeah, and then minus 1. So that's what we have it factored into. So we notice what I wanted to get to here is this changes our P and Q when we're looking for the other zeros. We still have to do some more synthetic division to find the other ones, but in this new set, it can't be plus or minus 12 for the P, and it can't be plus or minus, it just takes that one out. But it just takes that one out of that side, but it also takes out a 4, because 6 isn't divisible by 4, right? So when we're trying new things, we're not going to do the ones with 4 in it. And so it trims it down even a little bit further. We're going to learn even more ways to trim things down later. This last one here is what's really nice, because this takes out a bunch of options, right? Takes out a bunch of options there. Oh, I did it backwards. I knew there was something bugging me. Did y'all? I'm sorry. I warned you. I said mistakes are likely to happen in this video. It's like 4:30. My brain doesn't work after noon, it seems like. It's the other way around. This is P, right? So this is P. So that's much more useful. We can go, right? And then Q is where we trim. And this Q didn't change. So all of these are same. So it's going to be 1 over 1, 1 over 2, 1 over 3, 1 over 6. So one of those. So it could be 1. And we already said from the picture that 1 kind of looks like it works. So we should try a positive 1 and see maybe even negative 1. So we should try the plus or minus 1s in there and see what happens. See if we get those. So let's try it with a 1. Well, we're going to try it with this new setup here, right? Because we've shifted and we're trying to find the zeros of this, which would also be zeros of this. But we can use these new numbers now when we go. So once we find ones, we get easier numbers, which is nice, right? So let's try a positive 1. We'll do it with 6, negative 2, 3, negative 1, right? Bring down the 6. 1 times 6 is 6. Negative 2 plus 6 is negative 4. 1 times negative 4 is negative 4. 3 minus 4 is negative 1. 1 times negative... Oh, it didn't work. Shucks. Okay. So that didn't work because that's not 0. Let's try negative 1 just to see. Negative 1. Again, we're using our new numbers since we found a 0. 6, negative 2, 3, negative 1. Oops. Bring down the 6, negative 8. This is positive. This is not going to work either. Okay, let's use my cheat brain and let's try a third. All right, let's try a third. If you were doing this, you might guess and be like, oh, let's try the thirds next, or you might go to the halves. I don't know. All right, because it could be any of these. 1 divided 1/2, 1/3, 1/6. It could be any of those, right? So let's use the cheat brain and try 1/3. So 1/3. Try it with the new coefficients. 1. Bring down the 6. 1/3 times 6 is 2. Ooh, we like that. We likey that. Negative 2 plus 2 is 0. 0 times 1/3 is 0. 3 plus 0 is 3. 1/3 times 3 is 3. No, 1/3. I didn't make the mistake this time. 1/3 times 3 is 1. Negative 1 plus 1 is 0. So now we factor. Now this is really handy. This is really handy. Where this is factored into is f of x equals x plus 12, right? That one up there that we found, plus 12, times x minus 1/3, right? Flipping the sign there. And then times 6x squared. It would be 1 less than this one, right? There's no x term, so plus 3. Now, this one, you might notice that if we were to find this out, then we would get an imaginary number. Because we do 6x squared plus 3 equals 0. We'd subtract 3 from both sides, and we'd ultimately end up with x squared equals negative 1/2, and then square root that, and we get plus or minus I times the square root of 1/2. Right? Or the square root of 2 over 2. And so we don't have any more real zeros at that point. So we are actually done with this. The 2 zeros that we found, the last part of the answer is negative 12 and positive 1/3. If you want to put this in interval notation and then this in set notation, or if you want to label it, just some way that it's clear that this is the interval. You could even label this as the interval. You could label this as the zeros. However you do it, make it clear this is this thing and that's the other thing, because they kind of look similar, right? So that's it for that lesson. We'll see you in the next one. We'll narrow our ways to find possible ones even further next. See you then. Bye-bye.